All right, this is lesson 3 of our functions unit for grade 11 academic, winter 2024. Let's go. So we've got some good old quadratics review here, just to make sure we're still comfortable with everything. So remember, for vertex form, we've got 3 important pieces of information. We've got A, which is our direction of opening, and our vertical stretch, we have K, which is our vertical shift, or more formally, a vertical translation. And then we have H, which is the horizontal. Translation. Sorry for the handwriting. I'm not super used to my tablet just yet. All right, focusing on A for a moment. If we have a positive A value, that means our graph is going to open up. And a graph of a quadratic is a parabola, so it's going to look something like that. Conversely, if we have a negative A value, this parabola is going to open down. This is all review, so we should be pretty comfortable with this so far. Now, everybody's favorite thing from the review package, completing the square. So if we have a function, a quadratic function, f of x is equal to x squared plus 5x plus 7, we can get the vertex by completing the square. So let's go through that process here. So remember, we are starting with ax squared plus bx plus c would be our standard format for these. So if a is not equal to 1, we would have to factor that out. But in this case, we don't have to. It's already 1. So this time, we're going to start by looking at b. B is equal to 5. We're going to need to know what half of b is, b over 2. And in this case, that's just 5 over 2. And we're going to need to know what b over 2 squared is, which is 25 over 4. And as a reminder, this is what we're going to add and subtract to create our perfect square. And this is going to end up being our h value, our number inside the brackets with x at the end. So continuing on, we have f of x is equal to x squared plus 5x, plus our b over 2 term, plus 25 over 4. We can't change the equation, so we have to also subtract 25 over 4, and then we have our plus 7 left over. So this is our classic math trick. We're going to add and subtract the same thing. We didn't change the equation, we've just added 0 in a really fancy way. Once we do this to complete the square, these first 3 terms are a perfect square now. That's why we added the b over 2 squared. And this first perfect square will be x plus whatever our b over 2 was, 5 over 2 squared. And then we just have to tidy up what's left. So in this case, we have subtract negative 25 over 4. Let's convert 7 to be a number over 4. So that will be plus 7 times 4 is 28 over 4. So we have x plus 5 over 2 squared plus 3/4. Negative 25 plus 28 gives us 3/4. That means our vertex is going to be our h and k. So h is in here, but it's the opposite sign. You never trust a number in the brackets with an x. Negative 5 over 2. And our k value is over here, 3/4. Now, for those who don't like completing the square, there's actually another way to find the vertex. And it's called partial factoring. If you like partial factoring, great. If not, you don't have to do it. This basically uses the idea that all this C term does is move the graph up and down. So if all that does is move the graph up and down, it's not going to change the axis of symmetry, right? The position of the graph horizontally and the stretch are all preserved. All that does is move the graph up and down. So the axis of symmetry doesn't change. So what we're going to do is we're going to ignore our C term. So we will just think about negative 2 over 3x squared plus 8x. And you notice I did not do an equals sign because this is not equal. I have changed the equation by doing this. And now I can just common factor to get 2 points that I can use to find the axis of symmetry now. So I'll take out a negative 2 over 3x. And that leaves me with an x. 8 divided by 2 is 4 times 3, because I would have to basically multiply by the inverse to see what dividing was like. Will give me a negative 12 in my bracket. And this gives us kind of like our two terms. So in this case, x would have to be 0. Whoops, pardon me. We'll go back a little bit. We're going to act just like we are finding the roots of this altered equation. So we set that to 0, and that means either x is equal to 0, because that would make this whole piece 0, or x is equal to 12. So these are the roots of, we have like a family of quadratics that are all the same shape, just moved up and down. And this is one of them. It's not the same as our equation, but it has the same axis of symmetry. So I can use these roots to find the axis of symmetry of this equation, and they're the same as the axis of symmetry for that. So my axis of symmetry, x is equal to my two roots added together, divided by 2, which in this case will give us 6. And then we will just evaluate f at 6 to get the vertex. And that's this equation, not our modified, our original one. Now that we have the axis, we use the original equation. So this will be negative 2 over 3 times 6 squared plus 8 times 6 plus 5, which is equal to negative 2 over 3 times 36 plus 48 plus 5. And you could use your calculator at this point if you wanted to. 36 divided by 3 is 12. Times negative 2 is negative 24. Plus 48 is positive 24. Plus 5 is 29. Ugh, terrible writing. Sorry. 29. So therefore, our vertex is 6, 29. So two ways. Make sure you understand how to complete the square, and then if partial factoring appeals to you, then that's an option as well. Moving on for today. This is very similar to a lot of our review stuff. We've got essentially a revenue question. So Rachel and Ken are knitting scarves to sell at a craft show. The wool costs $6 per scarf, and they plan to sell them for $10 each. Last year they sold 40 scarves, but for every 50-cent increase in price, they will sell 4 fewer scarves. What price will maximize the profit? Okay, so this is a profit question, but essentially it's asking revenue. It works very much the same idea. So we're going to start off, let X represent the number of price increases okay. Then we're going to make our 2 linear equations. One is for the profit per scarf, so let's call that our price. So our price equation in this case, normally they buy for 6, sell for 10. So normally they make $4 on each scarf, and we are going to be increasing by 50 cents. So plus 0.5 times the number of price increases. And then we're going to look at our number of sales. So normally they sell 40 scarves, but every time they increase the price, they expect to sell 4 less. So that's going to be 4 less for every price increase. And then our revenue is equal to our price times our sales, which in this case is 4 plus 0.5x times 40 minus 4x. And we want to maximize this. So you have 2 options from here. Option 1, multiply, expand and simplify, collect like terms, complete the square. Since this is so nicely in kind of factored form for us, I think I'm going to use the roots, find the axis of symmetry, and do it that way. So to find the roots, we set our revenue to 0. That means one of these 2 brackets is equal to 0. So 4 plus 0.5x is equal to 0. So 0.5x equals negative 4. So x is equal to negative 8. Or 40 minus 4x is equal to 0. In this case, 40 equals 4x. And 10 is equal to x. So those are our 2 roots. Now, find our axis of symmetry. So the axis, x is equal to the average of our 2 roots, negative 8 plus 10 divided by 2. Negative 8 plus 10 is 2, divided by 2 is 1. So whatever our maximum profit is, it's going to have 1 price adjustment. Let's find what the maximum profit is. So R is equal to 4 plus 0.5 times 1 times 40 minus 4 times 1 which is going to be 4.5 times 36. You run that through your calculator and you will get $162 for maximum revenue. And the only thing we haven't looked at here is at what price will this happen. So the price that will cause this to happen is our 4 plus 0.5 times 1, or $4.50. And then we'd use a therefore statement that a price of $4.50 will maximize the profits, and that maximum profit will be $162. Last one for today. Man, this note really is just all from our review, isn't it? So we have a projectile motion problem. Jamie throws a ball that will move through the air in a parabolic path due to gravity. The height in meters of the ball above the ground after t sections can be modeled by the function h of t is equal to negative 4.9 times t squared plus 40 times t plus 1.5. So let's make a little sketch. Always good to make a little sketch. So my c value is a positive number. That means that my ball is going to be starting above the ground. And then it's going to be thrown, and it's going to land somewhere over here. And we understand the graph would continue this way. It doesn't really make sense for reality. We don't know what the ball was doing before Jamie throws it. But just in terms of how parabolas work, we know it would continue, and there would be a root on that side as well. And then this would be a height of 1.5. So let's find the zeros and interpret their meaning. Well, we can already interpret their meaning. That should be meaning. Good job, Mr. Leggett. There's going to be a negative root that means absolutely nothing, and there's going to be a positive root that represents the time the ball takes to land on the ground. So how are we going to find the roots, the zeros, the x-intercepts? I've got this yucky number I don't think I want to factor. Let's go straight to the quadratic formula. So x is equal to negative b, negative 40 in this case, plus or minus the square root of 40 squared minus 4 times negative 4.9 times 1.5. And all of this is going to be over 2 times a, which is negative 4.9. Where did I put my calculator? I'm going to need that in a minute. All right. So this is negative 40 plus or minus, let's simplify our square root, 40 squared minus 4 times negative 4.9 times 1.5 gives me 1629.4, and that's all over negative 9.8. And now we'll calculate it through. Negative 40 plus the square root of 1629.4 equals, divided by negative 9.8 equals, well, there's my negative root, negative 0. Let's do 2 decimal places, 0.4. And then let us do the other one, the subtraction, negative 40 minus the square root of 1629.4 divided by negative 9.8 gives me 8.2, smudge, 8.20. So there are my two roots. So this is nonsense, and this is the number of seconds it takes for the ball to land. Which is represented by that point right there. So how long does it take the ball to reach its maximum height? We need to find the maximum minimum, the vertex basically. We could complete the square. The numbers are not very pleasant. It's not going to be fun, but we already have the roots. So why would we complete the square if we already have the roots and we can just use those? So the time needed to reach its maximum height is going to be the axis of symmetry. So it's the same distance from there to there as it is from there to there. So I can average my two roots. So for the axis of symmetry, x is going to be equal to negative 0.04 plus 8.20 divided by 2, negative 0.04 plus 8.2 divided by 2 gives us 4.08 seconds. So this is x equals 4.08. And then it asks us to find what is the maximum height at the ball of the ball. So that's going to be the value of h at this axis. So I just noticed that I have been using x's instead of t's. I apologize for that. Sometimes we get so used to using x's and y's that we don't even notice when questions ask for things in a different way. But technically, that's a t, and that's a t. And I can't make that one go away. Anyway, this is a t for our graph as well. Maximum height of the ball. Sorry, lost focus. So I want to calculate h when t is 4.08. So h of 4.08 is equal to negative 4.9 times 4.08 squared plus 40 times 4.08 plus 1.5. We'll run that through the calculator, and we should get an answer of 83.1 meters for the maximum height. And that's everything for today. Great review for stuff that we haven't covered yet. You can see the practice problems at the bottom of the page. Yeah, and you get that through that. That'll bring us back to Monday. And make sure you take a look over these first 3 notes, because we'll probably have a quiz next week on either Monday or Tuesday on everything we've learned about functions so far. Take care. Bye.